In a prior video, we talked about how the sun moved up and down in the sky over the course of the year in different locations on different days. But what about the sun's highest point in the sky on any given day? This is the concept of solar noon, which we will explore in this video.
Here we again have the Earth oriented on one of the equinoxes, where the Earth is pointed neither towards nor away from the sun, but the axial tilt is in fact sort of perpendicular to the incoming direction of the sunlight. As discussed elsewhere, on this day, a stick on the equator will generate no shadow because when the sun is directly overhead. This moment is called solar noon. At points north of the equator, the sun will not be directly overhead. We can see the stick creates a shadow that points north, but the sun will be as high in the sky as it gets. It just will be south of directly overhead at this same moment of solar noon, the moment where the sun is the highest in the sky. At this same moment in the Galapagos Islands, off the coast of Ecuador, it is sunrise. Our whole stick is visible. The sun is right coming up over the horizon. So when it's solar noon on the prime meridian of 0 degrees longitude, it is sunrise at longitude 90 degrees west, a quarter of the way around the world. And it is sunset at 90 degrees east, a quarter of the distance around the world the other way, and it is midnight on the international date line at 180 degrees longitude. Now, of course, the Earth spins once every 24 hours. That's called a day. Since there are 360 degrees in a circle and the Earth goes around once per day, that means that the Earth goes around in 1 hour. 1 over 24 equals x over 360, 15 degrees every hour. So 1 hour after solar noon on the prime meridian, it is now solar noon at 15 degrees west longitude, and 1 hour after solar noon on the prime meridian. 1 hour later, it's solar noon at 30 degrees west longitude, and now it's 2 hours after solar noon on the prime meridian. And so on and so forth as the world goes around.
There's one last complication to this whole thing. Solar noon is unique to each individual line of longitude on the planet. This would be really inconvenient in our modern life because it would mean noon in Amherst, Massachusetts would be different than noon in Northampton, Massachusetts, which is only 8 miles to the west. And it would mean that if you were trying to catch a bus, you would need to know what time it was in each individual city you pass through, which would change even mile to mile. To alleviate this problem, we as a species invented time zones, where we just kind of agree that everyone within a certain region has noon at the same time. For example, Boston, New York, and Peru all have noon by agreement at the same time, 5 hours behind noon in England on the prime meridian. While this makes things useful for everyday life, it does mean that there's a discrepancy between solar noon, when the sun is the highest in the sky, and noon on our watch. The only place in the world where this actually matches is in Greenwich, England, and other places on the prime meridian. Everywhere else, noon on your watch and noon as told by the sun probably don't match. So you need to actually measure solar noon at any given place you're in.